Hello and welcome, and in this video we're going to be covering operations with functions. Now, operation with functions really isn't that complicated at all. If you have already taken Algebra 1 or you're currently in Algebra 1, as long as you generally know how to combine like terms and multiply like polynomials, this actually really isn't anything more than that. It's just that we're now writing it in function notation. So I have three functions up here. I have f of x, I have g of x, and I have h of x. And each of them are either like a linear or a quadratic. It could be really anything. We can do this with any type of function, okay? Now, operation with functions, we're talking about addition, subtraction, and multiplication. Now, you can divide functions just like you can divide numbers, but it gets a little bit more complicated with division. I'll be covering that in a future video once we start talking about polynomials, because we actually use division in a very nice and special way. Okay, so today we're going to focus on addition, subtraction, and multiplication. So for example, let's say I wanted to do f of x plus g of x. I wanted to find out what f of x plus g of x is. Well, all I'm really doing is I'm now just substituting in 2x minus 3 for the f of x function. So this is going to be 2x minus 3. That's f of x plus, and now I'm going to add it to the g of x function, which is 4x plus 1. And then from here, it's just combining like terms. That's all that a function addition is. So I'm going to go ahead and combine like terms. So I can combine the 2x and the 4x. So it's 2x plus 4x, so that's going to get me 6x. And then I'm going to go ahead and combine negative 3 and positive 1. So that's negative 3 plus 1, which gets me negative 2. And that would be it. That's my final answer. It's as simple as that. So that's function addition. The only thing I also want to bring up with function addition is we can now have it written a little bit differently in kind of different notation, okay? You could see it as f of x plus g of x. Or you could see it as f plus g of x. Just know that these two mean the exact same thing. So I can give you the notation f of x plus g of x, or I can give you the notation f plus g of x. They represent the exact same thing, okay? So that is function addition. Now I could change it up a little bit. And actually have us add these two functions at a specific value. So for example, I can give you something like f plus g. Instead of x, I can say of 2, okay? And you can rewrite this kind of in a long form way if you want. What this would represent is f of 2 plus g of 2. That's all that represents, okay? Now, when we are either adding or subtracting at a specific value, there's kind of two different ways you can do it. You can either add the two functions together just like we did up here and then substitute in the value of 2, or you can substitute in the value of 2 into each function first and then just perform the operation. So I'm going to go ahead and actually do it both ways here. So let's say I wanted to first perform the addition. Well, I actually did that already. Remember, f of x plus g of x is 6x minus 2. We just did that. From here, I can now go ahead and substitute in the value of 2 for x. So if I did that, that would be 6 times x, which I want to find out when x is 2, minus 2. And this would end up getting me 12 minus 2, which ends up getting me the answer of 10. So that is one way that we could have done it. The other way we could have done it is by actually substituting into each function first, evaluating it at that value, and then just perform the operation as, in this case, addition. So for example, if we did that, that would be, okay, well, f of 2 would be 2x minus 3. Well, x is 2, we're saying, minus 3. I want to find out what that is, plus, and then g of 2, which would be 4x, I'm saying is 2, plus 1. And if we did this, we would end up getting 4 minus 3, plus 8 plus 1. And then we just make sure we're performing order of operation. So this would be 1 plus 8 plus 1. That would now become 9 plus 1. which once again gets me 10, okay? So that's how we can do function addition as well as function addition at a specific value for x. Now let's take a look at subtraction. For example, let's say I wanted to find g of x minus f of x. Well, I would pretty much do the exact same thing. I would now substitute in my g function, which is 4x plus 1, for g, minus now my f of x function, 2x minus 3 for f of x. The only thing that you got to be really careful of here is that we are subtracting an entire function. So I need to make sure that I actually distribute that negative to everything in that second function. So what I do recommend doing is putting parentheses around your functions. With addition, it's not as necessary, but with subtraction, it's generally a good idea. That way, we can take care of distributing the negative. So this would now look like, well, I'm not doing anything with this one, so this is going to be 4x plus 1 minus 2x plus 3. Because what I had to do is I had to distribute this negative to everything in the second function. So make sure that we're being really, really careful when we are subtracting functions. Because now, instead of getting the answer, now the most common mistake would just be doing 4x minus 2x and then 1 minus 1 and then minus 3 instead of 1 minus negative 3. So just be really careful, distribute that negative, because you should now get the correct answer of 2x plus 4, because we just go ahead and once again combine like terms, 4x minus 2x, and then 1 plus positive 3. So that would get you 2x plus 4. Once again, you could see it in that other notation. You could also see this as g minus f of x. So you can see it in either of these notations. Once again, though, they represent the exact same thing. And just like with the previous problem with addition, we could ask you to evaluate it at a specific value of x. So this can be like g minus f of 4, or it could be g of 4 minus f of 4. We can actually evaluate it at a specific value. So just make sure that we're able to do that as well. And the last one I want to talk about is multiplication. So let's take a look at multiplication. So in this one, I see f times g of x. We have like a closed dot there. We're not going to necessarily going to be using the x for multiplication. We're always going to be using dot. Okay, so this represents f of x times g of x. So you can see it written like this, or you can see it written like this. Just know that both of them represent the exact same thing. And what we're doing here is we are multiplying. So this would be the function 2x minus 3 times the function g, which is 4x plus 1. And now what we would do is we would multiply these functions together. So you should know how to, what a lot of people call FOIL, okay? You should be able to multiply binomials, trinomials, all of those together. So now I would go ahead and multiply these out. So I do 2x times 4x and 2x times 1. So that's going to end up getting me 8x squared plus 2x. Right, and then I'm going to have to do negative 3 times 4x and negative 3 times positive 1, which is going to get me negative 12x minus 3. And now all I have to do is combine like terms. I just got to combine like terms, which are going to be these two terms in the middle. And that's going to get me the answer of 8x squared minus 10x minus 3. So that would be my final answer. Now I do want to cover one that's maybe just a little bit more complicated. I want to say complicated, just a little bit more involved. Let's go ahead and take a look at something like, let's say I had g of x times h of x. Well, once again, this would just be two functions multiplying each other. So I'm doing g of x, which is 4x plus 1, times h of x, which is x squared plus 3x minus 1. But we're still just multiplying, we're still just distributing like we normally would. So I had 4x times x squared, I would have 4x times 3x, and I would have 4x times negative 1, which is going to end up getting me, well, 4x times x squared would be 4x cubed. 4x times 3x would be 12x squared. 4x times negative 1 would be negative 4x, right? And now I just got to distribute the positive 1 to everything. So I do 1 times x squared, 1 times 3x, and 1 times negative 1. So that's going to be 1 times x squared is x squared, 1 times 3x is 3x, and 1 times negative 1 is negative 1. And now once again, I would just combine like terms. 4x cubed does not have any like terms, so I just bring it down. 12x squared plus x squared, those are like terms, so I'm going to combine those to get 13x squared. I have negative 4x and positive 3x. So I'm going to combine those to get a negative 1x. And then negative 1 has no like term, so I'm just going to bring that down as negative. And that would end up being our final answer. So that's it. That's all that function operations are, or operations with functions, whichever way you want to word it. Okay, so it's just the exact same as adding and subtracting polynomials, which is just combining like terms for the most part, as well as the same as just multiplying polynomials. So a lot of you guys will recognize it as FOIL. Okay, really what you're just doing is you're multiplying polynomials. Okay, so I hope this video was helpful. If you have any questions, please feel free to let me know, and I will see you guys in the next video.